The next experiment we're going to look at is lens systems, and if you read the lab manual before the class, like you're supposed to, but nobody actually does, then you'll know it's one of the more involved experiments. So we're going to be looking at the behavior of a large-scale lens system, in essence. So we're familiar with the idea of simple lenses and the thin lens maker's equation, where we can measure some simple parameters of the lens, its radius, its thickness, its refractive index, all these kind of things, and use it to work out the fundamental behavior of it as an optical component, so determine its focal length, all these kind of things. But increasingly, when we're looking at more complex optical systems, they might be composed of, a huge array of different lenses. So classic example from first year, maybe you remember building the telescope. So you built, first of all, you built a 2-lens telescope, and that's easy enough. You have the objective, you have the eyepiece, and it's easy to work out its magnification and all these kind of things. But as you add in complexity, so you add in, the field lenses, the erector lens, all those things, and you have the 5-lens telescope. Yes, first of all, you get better behavior, better performance, all these kind of things. But it also becomes harder to calculate the path that the light takes as it passes through the lens system. And the key thing that we want to do when we're dealing with more complex lens systems is be able to determine their behavior. And so this experiment is designed to look at how we can do that for a fairly complex lens system. So in our case, we're going to use the telephoto lens of a camera. And we're going to, like an old-fashioned camera, by the way, like, the ones that the paparazzi use to try to get photos of me coming out of the shower. But yeah, so we're going to look at finding the 6 cardinal points of the lens system. So the principal points, the nodal points, and the focal points. It's one of the more involved experiments, as I said. You'll find there's 2 methods for assessing the position of the focal points. One is fairly involved and gives usually a very decent result, and the other is very quick and actually often gives a better result just because it's a little easier to perform. So it depends on how well you perform the experiment and how precisely you take the readings. So that's my kind of intro to this one. There's a lot of material in this one, so it's one of the experiments that's probably going to be good to write up as a lab report. So obviously you want to pick an experiment where you're kind of able to demonstrate your understanding of the physical concepts. So if you feel that way about this one, because lenses is one of those areas that don't get covered in a huge amount of depth at universities anymore. But if you do feel confident about it, it's a good one to write up. Every year I get about 70% of the reports are on Newton's rings, and that's fine. But obviously if you do a different experiment, maybe it's easier to make your report stand out. I don't know. Worth thinking about anyway. But anyway, good luck with the experiment, and we'll see how it goes.